Okay, today we are going to talk about that 8051 multiplication. 8051 it is an microcontrollers. So if you want to do that multiplication operation means we need to get two numbers and multiplication that numbers, then we need to store that answer in different location. That's all the basic process. So we need to write the programs for that. So I'm going to explain that every instructions clearly. Okay, the first of all, here the move a comma 20, here we are going to transfer the data from the memory location 20h to a. Within the 20h memory locations itself we have the data. It may be 30 or it may be 41h, okay, like that. Okay, so inside these memory locations that 8-bit data is available. Okay, 20h it is an memory location, it is not an data. First of all you should know about that. Here we are going to transfer the data from the 20h memory location to a. Here I store the data inside the 20h memory location is 04h. It is an 8-bit data. We already know about that 8051 microcontroller. It is an 8-bit microcontroller. So we can store only that 8-bit data. Okay. So inside the 20h we stored 04h data. Okay. And 21h we are having the same data 04h inside the 21h also. Okay, here I am going to transfer the data from 20h to a. So inside the a registers now we store 04h the data inside the accumulators, okay, or a registers. Then after that we are going to move the second values, because first value already we transferred into the a registers. The second values to do the multiplication operations, the second data, I already said that within the 21h address also, inside this address we are having 04h values. So these values is stored inside the 21h address. Now we are transferring that data into the b registers. Now the b registers also having the 04h values. Okay, MULAB represents we are going to multiplication the two numbers. So if you multiply the two 8-bit numbers, we will get 16-bit values, 16-bit answer. Okay, if you multiply the two 16-bit number means we can get the 32-bit answer result. So here it will be doubled. We already know about the basics. So here we are multiplication, we are doing the multiplication for two 8-bit numbers. So we are going to get the 16-bit result. So I already said that if you want to store a 16-bit data, we need two memory locations, because on each and every memory locations we can able to store only the 8-bit data. So if you want to store the 16-bit data, we need two memory locations. So at 22 address we are going to store the result of the multiplications, the lower byte of the multiplications, because if you multiply the two numbers, 04 multiplication with 04, the value is 16. Okay, in hexadecimal form 16 is represented like 10h. Okay, so 00, this is the upper byte values, this is the lower byte value of these multiplications. So in 16-bit if you multiply these two numbers, we are going to get the 0010h values. Okay, the 10 represents the 16. At higher byte there is no values is available. So this 10, we are going to store this 10. Yes, A register having the value of 10, the B register is having the value of 00h. We already know that if you multiply the two numbers, the answer it will be stored inside the A and B registers, because after you do the multiplication process, the result only it will be available inside the A and B registers, because at initially we are going to we are having the values of we are having the input values inside the A and B registers, because after you do the multiplication at A and B registers we are having only the result. Okay, so we are transferring the data 10H inside the 22H memory location. Then after that the upper byte value of 00H we are transferring into 23H memory locations. Okay, because after that at the end of the programs we are going to jump for short jump. Short jump represents we can jump up to 256 locations. We can use the short jump. Upper side we can jump up to 128. At lower side we can jump up to 138 locations. Here we represent S jump. Here means we are going to jump here itself. Okay, so it's like a short jump. Routinely we are going to jump. It is the end of the programs. Finally we stored the data inside the 22H and 23H values. Okay, thank you.